our general rule of multiplication refers to events that are not independent. Whoa. When we have situations where events are not independent of one another, we have situations where conditional probability exists. So a conditional probability is the probability of a particular event occurring given that another event has occurred. So conditional probabilities are represented by using this, what's called a pipe. So it's a long, straight character. It is shift and then the button above your enter sign on your keyboard. So there's a backslash on your keyboard. If you press shift and you press that backslash at the same time, you end up with a vertical line like this. Kind of looks like a lowercase l, but it is significantly larger than your normally typeset fonts. So the probability of B given A is how we read this in English. Of B given A. So if they're not independent, what does that mean? That means they are dependent. When they are dependent, what does that mean? That means we have conditional probability. The value is conditional on what occurred in the first event. When we have dependent events and we're looking at conditional probability, we have a general rule of multiplication as follows. The probability of A and B occurring when they're dependent from one another is going to be equal to the probability of A occurring multiplied by the probability of B occurring given A has already occurred. So again, these things seem very arcane, difficult to deal with until we pair them with an example. So let's pair this general rule of multiplication and this new notion of dependent or conditional probabilities with a simple example having to do with 12 shirts. So we talk about a golfer having 12 shirts in their closet. We're told that 9 of these shirts are white and that the rest, the others, are blue. So we have 3 blue. We're told, let's suppose he gets dressed in the dark. And he plays golf 2 days in a row and doesn't return the shirts to the closet. That's an important part. So we're going to say dresses in the dark 2 days in a row, no shirt replacement. What is the probability that both shirts are white? What's the probability that both shirts are white? So let's put this in our conditional probability situation, right? So because of the fact that there's no replacement of shirts, that means that the choice the second day is dependent on what they choose the first day. So when we're writing this in our probability formula, we're going to look at getting a white shirt the first day and getting a white shirt the second day. This is going to be equal to the probability of getting a white shirt on that first day, right? Because the first day's choice doesn't have anything to do with the day before. That's the definition of the first day, right? But then when we're looking at the next day, depending on whether or not they picked a white shirt the first day, there's going to be a different amount of white and blue shirts in the closet. So when we're looking at the second day, we have to look at the probability of W2 given W1. And so for that first value, the probability of W1, right, we're just going to take the instances of a white shirt from over here, and we're going to divide it by the number of occurrences from over here. Pretty easy. But now we have to think about what is the probability of picking a white shirt the second day if I already took a white shirt out of the pile, out of the closet, and I didn't replace it. If I didn't replace it and I chose a white shirt before, then that's going to be 9 white t-shirts minus the 1 white t-shirt that I chose that first day. We're going to have a possibility of, not 8 days, 8 shirts. Now, what has happened to my blue shirts, right? I didn't select any blue shirts, so there's still a possibility of 3 blue shirts. And now how many shirts are in my closet? There's no longer 12 because I wore one yesterday and I didn't replace it. There are 11 total shirts in my closet. So we're going to take the number of white shirts and put it in the numerator over here. And then we're going to take the total number of shirts and put it in the denominator. Is everyone clear where we get the numbers for each of these numerators and denominators from this simple prompt? Multiplying these together, it's just simple algebra, and we end up with a probability that the golfer gets 2 white shirts in a row at 55%. And this can be extended to more than 2 events, right? And the book does a decent job of talking about, if you are pulling sodas out of a cooler, 5 of them are Diet Coke and 5 of them are regular, and you get what are the odds of you getting 3 Diet Cokes in a row? And then it walks you through this similar type of math, but instead of for 2 events, for 3 events. So if this is still not clicking exactly, please go through the book, read through this section on the general rule of multiplication, email me with any questions you may have.